My name is Steve Kinney. I am the lead teacher and technology coordinator at a school in Rockaway Beach, Queens.
Luke, I'm a technologist.
Jennifer, I'm a technologist, also a university professor.
So we're here today to talk about QueryUs. Sweet. Which you can see here, which is a play off of QueryUs, but with query. So just a general walkthrough of what we're going to talk about today. Basically, QueryUs is an interactive web-based system that allows for the simple manipulation of large data sets. In this presentation, we will address the following aspects of the project. One is learning objectives. Why build it? The development cycle and the process of building it. A walkthrough and a live demo. And then user tests and feedback. Learner tests, if you will. And when we put it in front of about 50 kids, what their reactions were and how they used it. And some things we expected, some things we were completely floored by, both good and bad. And where we would hypothetically take in the future based on that. So, primary learning objective behind QueryUs is to help students understand how to parse large data sets. Taking this from two different angles, right? There is the angle, I teach kids how to program, and Eric teaches them math, right? And for both of us, it was something that would kind of work together. For Eric, he teaches, kind of algebraic functions, right? Inputs and outputs, and a lot of times it's taught traditionally in kind of an abstract sense, right? You kind of learn how it works, and you go, all right, cool, I got this. And then the same thing when kind of looking at building a program. You can teach syntax, right? You can teach there's a semicolon or not a semicolon if you want to get into a fight about it. But then, there's also that part where it comes down to, all right, I want to make the next Tumblr, right? All right, so yeah, you can write a line of PHP or JavaScript, wonderful. But then there's that kind of conceptual understanding. Well, even before you write a single line of code, what does that look like, right? When you go to use one of these things, what does that look like? Because right now, for a lot of my students, it's black magic, right? There is an elf living inside of a box that takes their request and gives them back something, right? And kind of then taking away a lot of the mystery behind that, so they can think, okay, I now understand how that would work. Let me see how I would construct something like that. And there's the whole thing where they're using this stuff. A lot of, there's a college and career readiness part of that, where there's that whole big data thing I think someone mentioned, right? This is kind of making that very kind of a first kind of way to approach that. So one of the things that we kept thinking about as we were listening to some of the other groups talking about connections and stuff like that is in humanities there's this big push for primary sources. Right, if you want to get the real deal in the Civil War, probably one of your best things to look at is the Journal of a Civil War Soldier, rather than something distilled 9 times that you find something you can really attribute to what it was like during that time. And that works really well in social studies, right? But then when we bring kids to talking about data, right, we usually give them an article about a data set. Or we show them a graph. We give them something that's already kind of been once over in front of them and say, okay, try to make sense of this. And we come up with some lessons on fact versus opinion, and then we say, good luck, right? One of the goals for QueryUs was thinking, well, how do we take large data sets and take that same approach to primary sources so that here's the data, and here's some tools to make sense of it, and what conclusions can you draw on your own? All right. I thought it was on the slide. All right. Cool. So yeah, and I said this.
Skip it.
Now I'm not stressed out about Ralph telling me I only have 10 minutes. Is this you a minute? Oh, sure. Yeah.
Okay, so we had 2 goals in our development cycle. The first was to examine how raw data set can be intimidating to a lot of people, right? But we wanted to scaffold this experience so the students didn't feel overwhelmed. We found that when you present a huge data set, for instance a spreadsheet to students, they get overwhelmed and they don't know exactly how things relate to each other. So we wanted to try to make this into something that was easily sort of understandable to them, and something that they can manipulate without having to stress too much over how the data was laid out. And we wanted them to think about ways they could develop, how they could see the data in different ways. So we didn't want to abstract away everything, or we wanted to make sure that it was rigorous and that this system could work on very large sets of data, and even data that they introduce themselves. We wanted to make it as extensible as possible. Typically, if you give a given set of data, that's interesting in one sense, but students really, what we saw in the test, and we're going to go over that, is that they wanted to put their own data in, so we wanted to make it open for that. Yeah. Demo time. All right.
So I'm going to take you guys through what it would be like to actually be a student who would be using QueryUs. So students have two places they can start. They can either start off with a question like this or with a tutorial. I'm just going to show you the tutorial really quick just because it's actually a very important part of the tool. And if you were using the tool, you might not have seen what the starting page looked like.
Can I get full screen? Resolution is a little bit low on this projector. You might.
All right.
It doesn't want to do much, really.
Okay, so
You get this.
so new students who come in a tool, they can see this tutorial page. It says, welcome to QueryUs. I'm just going to read this really quick. Data is everywhere. QueryUs helps us make sense of this data and relationships. It has to form other forms of information by building queries, which are like mini search routines you'll be able to sit through, derive answers that we can share with the world. So they hit Let's Go. It says commercial search engines like Google, Bing, Yahoo use functions and algorithms that give you results when you type in questions. This is useful, but sometimes the results aren't what you wanted or are skewed towards companies that pay these search engines to display the results first. Let's change this with QueryUs. Are you ready to fight the power? They hit start. Now I'm going to move through a little bit more quickly since it's just a tutorial and you'll be seeing this twice. So I'll just go a really brief overview. So it just says, here's a question. This is just explaining it. This is the question you're trying to answer. These are variables. You can select them. The variables show up below here. You can then modify your query or basically try to filter out data. So you can select different options for what your query look like. There's less than, you can type in what you want. So less than 3, and then it says, okay, now that you've done that, the top has changed. And then once you're done, you can go and share with others by hitting publish. Great, it says, okay, now you have all the tools you need to go. Take any questions. So students will see different questions to choose from. I'm going to pick which colleges are good for you. So then again, it gives us a prompt of sort of getting the student in the mind of what they have to be thinking about. So it says choosing the right college could be the first important decision that you make with your life. There are a lot of important factors to consider when selecting college. Do you want to go to a big school or a small school? How much are you willing to pay in tuition? Let's go. So then I'm presented with the same kind of format as before. So let's say I'm a student who lives in New York, and I also want to go to a school in New York. So I'm going to click state, and then I want to say, give me all the rows that have a state that contains the letter, say, New York. So now you can see, now that I've said in New York, now all these schools are now based in New York. Let's say I'm really worried about graduating, so maybe I want to pick a school that has a really great graduation rate. So let's say graduation rate. All right, let's say a graduation rate that's greater than, let's say, 90%. Now I think it's important to note that you might have noticed that between state and graduation, the actual drop-downs have changed. So that's kind of a neat thing about QueryUs is that depending on what kind of data it is, the filters that you can select will actually change. And then what also is a great neat thing, which you can't see because of the monitor resolution, is that on the left here, it also gives you information about what's being shown right now. So it kind of gives you an overall picture of what you're doing. So you can see, now that I've filtered it, the lowest value is now, well actually that's reversed, it's a bug. The lowest value should be 91, and the highest value is 93, and then it gives you average, mean, and mode. So great, I'm pretty happy with what I got now. I've narrowed it down to 4 city. This is what I think is important to me. Hit publish.
We're both a little upset with our students for not noticing that.
So then it kind of gives me an overview of what I picked. So which colleges are a good fit for you? I want a state that contains the letters New York. I want a graduation rate that's greater than 90. And it shows me the 4 things that I've sort of narrowed down. And then I can say, well, I think this because I want to live close to home. Close to home. And I'm worrying about graduating. And then my iPad's gone too. So I hit save and publish, and then we haven't really built this out yet, but the idea is that you can see sort of what other students had picked. So the idea is I can say, oh, okay, when my other students, and I can see what they sort of picked and why they picked it. So now I guess we tried this out with students, and I guess Eric's going to talk more about how this went.
That's a walkthrough. So we went through several rounds of user testing, actually putting it in front of students. We did 3 rounds of user testing. The first was a small group of students trying it out and giving us that initial feedback. Based on that initial feedback, we realized that we really needed to build a tutorial. There was the students didn't have enough prior knowledge to really understand what the tool was meant to do and to break it down into all of the sub-questions necessary to be successful. So we built out that tutorial to try to orient them to the tool before they saw that first question. We went then into 2 sections of large class testing. First, I tested a class of 25 students, then Steve tested a class of about 26.
26, just
So in both classes, we gave it to them cold, but we wanted to think about the kind of the 2-part objective. First, to understand the web and to be kind of sophisticated in understanding what it is that they're doing when they go and search for something. And then also to think about those algebraic skills of understanding functions, understanding inputs and outputs, and try to transfer into their math skills. So I presented it in the math context, and Steve presented it in the web context. Great, so Steve presented it as web, and Steve has 8th graders. He led a discussion about the web after they experienced the tool. After both sets of testing, the kids took a detailed survey so we could collect their opinions about whether they liked it, what data sets they might be interested in seeing, whether they'd be interested to try this again, how successful they felt that they were. 60% said that they would like it, 27% were neutral, 68% they would recommend it to a friend. Largely, we were really happy with their response. Because actually, they on one hand responded they were very confused and that they really didn't feel like they knew exactly what to do. But they loved seeing and feeling real data. They loved that. One of the questions that I presented was, what were the top 20 musicians for 2012? And I gave them a set of 430 songs from 2012 and a lot of data about their position on the Billboard music charts. And they just loved being able to feel and mess around with that. Steve gave them the college data question that Steve showed you to. So we observed their confusions, asked their feedback. In the part where they have to post, we didn't have that fully built out, so what we did was have them move to the next guy's computer after they were done posting their query to try to simulate the experience of having a posting board, and to try to see what their feedback might be around getting to see other people's queries to see if that could be a feedback mechanism.
And we noticed that the first time around, like some of them they would go back, look at the results, and then use that kind of feedback to kind of go and approach it again one more time, and then they would get better at it through each iteration. Right, so they were as they got through the tool once, they used like kind of the results to inform as they went back in how they thought about, okay, now I kind of, have a better feeling for how this works. Let me approach it again, and now I kind of know how to set this thing up a little better for myself to get the results I want. Because you can kind of see, it's kind of, especially because it isn't like, except with the hippopotamus example, where you do not want to get eaten by a hippopotamus, there isn't really a right answer. So, if you're kind of generating your own set of data, so they can kind of say, well, this isn't exactly what I wanted, right? How can I go back and kind of refactor to get a query that more fits in with something that I wanted to do?
I also had them take a survey where they could generate their own data, and that's definitely a possibility for them, taking student-generated data and then putting it into the tool, having them find their own data sets and then clean them up and putting them in using public data resources. they had lots of suggestions for data that they would like to put into it. They just wanted to find out everything about, like, well, what's the best restaurant near us? Well, what's the best hotel? Like, what's the best could you think of? They wanted to put it in there. That was a nice quote. I think that's just reiterating that they really liked that it was like about music or about college, some of the things that are relevant. That definitely was interesting to them. But, so some things that we're still kind of wondering about, things that we've noticed, is that there are so many possibilities to search, and so many sub-questions to really be successful with an open-ended question that students were very confused. So you notice that what Steve was doing when he had to answer what the best college was, he had to think, well, I want to be in a small school that has a high graduation rate. I already am thinking that that's one of my requirements for picking a college. He's breaking it down, and maybe we had a little bit of expertise blindness in how many steps are there really necessary. So after that, after I did my testing, I went through a lesson with them where we went through very small questions, like can you succeed at doing a very close-ended query, where you find exactly this number, before we give them the open-ended query that's based on lots of sub-questions. So we saw that there's a lot of scaffolding needed, and we want to build that into the experience so that they can take those steps with the app itself to get to the open-ended, because that was really our goal, is that they can use it as an argument builder, not just to give an exact answer, but to have an open-ended question that has more than one right answer, that they have to make an argument for why their query is the best one. So we saw that. We love that they were doing possibilities. We saw that it was really good if you put it into a classroom setting. Like if you use it as a classroom manipulative and put it into a lesson, maybe into a unit, and use it throughout the unit, but you have to, so that you're teaching all of these sub-skills. Like if you have to pick what is the highest rank of something, but ranks go from largest to smallest, like the highest rank is 1, you have to use the less than function. You have to work through all of these subtleties, and maybe in a unit, you would go through these using the QueryUs tool as a classroom manipulator. I'm definitely planning on doing that next semester in my data analysis unit. We're really excited about the possibilities. We think that students with QueryUs can fight the power, learn about how the web works, that they can break through the gateway of understanding functions and get into those upper-level college classes, that they can get out of those remedial classes when they get into college, and that they can be successful. Thank you very much.
I think maybe Dan will do 5 minutes for questions, but I think since you guys, 5 minutes for questions.
I think you guys are right on in kind of solving out the most interesting thing of this, which is what we all have to do in real life, which is use objective data to try and find not the right, but the best answer to a subjective question. This is kind of more of a comment than a question, but have you thought about really making the query actually what they're doing really top line all the way through? Because the way it's designed right now, it's kind of buried down at the bottom, and it seems to me like treating the query like an object is the real win here. And you do, obviously, when you get to the end, you're showing everyone's queries, but actually treating what factors we're looking at as a big top-line data, I think that might help really reiterate that point that the choices that you make about data are what we're really interested here in the functions, rather than an actual answer, right? It's what choices did you choose to include, and then, like you ask people to explain that at the end, I think you might get more interesting answers at the end if that's always front and center and always a really big part of what's going on, both in terms of the design of the system, but also just visually, really having that, here's what results you're seeing right now, and here's why, because you made these choices.
I think that's a really good point, because like what I said before, where when the kids saw everything together, that's when they started to rethink how they approached it. If they saw that earlier, that might prevent them from having to go back on.
Don't you think that ties into the questions around whether we should put the data set in the center or not? We ended up going with put the data set in the center so that they could see the data changing, like to kind of see the data set shrinking, but you don't really see the data set shrinking because it's bigger than the whole screen. Those conversations were like absolutely there, and we made one choice, but we'd love to look at different choices.
I don't know if this is where Luke is going to.
Yeah.
But there's also a little button which they didn't show during the demo that lets already any teacher upload any open data set that's in CSV file format can already be uploaded.
Yeah.
It might need to be cleaned. So I think it's a similar question to Linky about, these aren't just tools. You have to think really deliberately about how you design the learning around it and how it's very, because it's not like a tool can be divorced of the content. They flow together. But I don't know if
I was just going to real briefly that we sort of tried to touch upon that about if you actually, I didn't have time to explain the tutorial, but when you start typing in the equation, it actually kind of makes like a brief equation overview. And it was part of the problem was that we really wanted to do that, but it was like, how do we compactly deliver that information? Because otherwise it's going to take up too much room in the thing. But it's definitely something we were considering. It's definitely a problem.
We have to prioritize it over the data set. We'd have to choose a different design.
Yeah.
Absolutely.
Okay, the last slide, you basically state that this is like something for a niche market. Like it's not going to be a universal concept, right? It looks like it's going to be for a C++ class or etc.
No, I use it in my math class. No, it would be available for every integrated algebra teacher in the city. Definitely, it's a statistics and data analysis is a common core standard that every single math teacher would have to teach.
So I also want to say that I can envision like a lot of possibilities for like English class, like it really anything where you're using data or like science stuff where you're like taking inclusion. Like there are a lot of different. I think it's cool because your ability to like upload things.
Some of the data sets,
data too.
yeah, some of the data sets we were playing with like human genome data and MTA data, and then we eventually had to just pick 2 data sets that that we could use in just to get the test done without a lot of background. But there was all sorts of data sets that we put, they all plugged right in, and you could kind of use it with. I happen to teach programming, so that's kind of where I was going with it. And he teaches math, but that's only because that's the content areas that we have background.
So I think it was born out of those two, like programming and mathematics, but the major reason why mathematics is so relevant now is programming.
Let's try one more question.
Just a general comment on the interface. I almost think you could show a little bit more of the seams in terms of really exposing the math and computer science of it. So really showing that the left column, those are called variables or something like that. And maybe not necessarily mixing the like human language semantics with contains the letters. Maybe actually having students put in a programmatic phrase. So whether it is equals or greater than, because I feel like this is great and it's nice to have students play around with data, but my question is, what's next? If they want to get into the good stuff, they're going to end up having to write some kind of code, whether it is, like a SQL-based code or, going a little deeper. So I feel like if you can start them on that now, it might be,
Yeah. One of the things we wanted to explore was ways to start peeling back the layers of abstraction, right? So one, because just dumping them in front of a console and a large data set is a recipe for very unhappy students, right? So having some way, like this was the first step, and then trying to figure out, well, how do we eventually get them there? How do we kind of scaffold it all the way so that they are, when they leave our classrooms, they can do it on their own.
Yeah, I kind of think that one of our goals was like this, this query equation, the idea is that it would actually be editable, and you could at one point go in and say, the only issue we sort of strayed away that a little bit just because it's agnostic. Like we don't want to say you have to learn SQL or you have to learn a certain language for querying, because obviously there's a bunch of different query languages. So right now we kept it sort of generic, but I'd imagine in the future it'd be really cool if you could say, okay, I want to put an SQL statement here and just write it out, and then it would generate all that stuff you see. It would be really cool feature to have.
It's all based on how much scaffolding we can give them
And then if it
what
was
their
a
prior
social
knowledge is going into it.
Yeah, if it was a social studies teacher and they just wanted to use like census data or election data, they might not want that. But then, for one of the 2 of us who definitely did want to go that way, that would be kind of, some switches you can flip, kind of depending how you want to take it.
Thank you all very much. We appreciate it.
Thank you.